All right, I think it's 4 o'clock. Let's get started for our session. I am Doug Rao, research scientist with North Carolina State University and NOAA's National Centers for Environmental Information. And today's session is called Towards Operationalizing AI-Ready Data. And I emphasize in the word towards because there's some discussion going on at the end of the session. We don't offer all the solutions that we think we have. So we want everyone's input on the efforts we are moving towards in the future. So this is a session by Data Readiness Cluster. We have 3 speakers today, including myself, Gerpen from University of Alabama Huntsville and NASA Impact, and Raina Jenkins from the World Data System International Technology Office. And before we get into specific details, I want to remind everyone that you can go into the collaborative documents on the sketch page to provide, just leave your information there. We can follow up and understand who we have here. And at the same time, I want also just quick poll to see who we have here in the room, where I see still a few people are trying to join, trying to take a break from the conversation during the break. So here, just, if you can scan the QR code on the screen here. I will also copy the link into the chat. So just to see who we have in the room, it's the most accurate description. You can choose up to 3 that describe your role in data management. So if you can scan the QR code. Still nobody responded yet. Oh, 1. You see this for AI ML applications? You can choose up to 3, so you don't need to limit to just 1. I am a data officer. Thank you. Technology developer. I create data set, I manage data set. Developer, great. I work for a data center. I think for people who just joined, we're just trying to use a QR code to understand who we have in this room before we get into our discussion today. We have a lot developer in the room, which is great. Also, data center staff. Okay, we'll give it another minute or so for people to fill in this question while also letting people settling down just come into this room. Okay. Seems like we have a lot developer and also data center people, which is great. Also, this slightly different than Slido. This will be open all the time. You can go back and forth between different questions as you wish. So this will always be open. So if you have the time later, please fill that in as well. And I will go back to our slides today. So just a few backgrounds for setting this discussion today. I think nobody would argue that machine learning is not popular. But this slide still just give you a general number of some of the publications in the IEEE and IEEE Geoscience Remote Sensing Society publications. Overall, you can see the trend rapidly growing. This, you can find similar figures in almost any field if you want to just try to do a Web of Science search and then plot it out against here. This is not rocket science like many of we do in this room. And in together with the general trend for the technology developments in geoscience, we have been rapidly adopting the machine learning in that. And to give a little more history, I just also want to add some of the more notable model development in machine learning domain and in the context of this figure. So on the very left side, you have the long short-term memory network and Lagoon nets from the late 90s, which is basically the beginning of the deep learning or the deep learning model structure, where the most prominent deep learning network has been used in the recent days. Often you have been seeing the citation in 2012, 2014, 2015, and then transformer is the one that blew everything up in 2017, and the vision transformer is the one that also gains a lot of attention in a lot of different imagery and video related tasks in 2020. You'll see a big gap in between the late 90s and then 2012. The reason there is a huge explosion of different models, model structure being developed, there's a very important development, which is something called ImageNet in the computer vision, which is benchmarking data sets that people collected all those imageries and labeled it. And so that's when all those different deep learning networks have been developed and benchmark against each other, because now everyone can just grab an easy data set and then develop their model structure and test it out and try to compare it with other people. There are other different sets of the benchmarking data that have been developed along the line. So that's why data plays a huge role in addition to the computing advancements in machine learning explosion in the past decades. And let me hide this floating panel. And how many have you seen this paper called "Everyone Wants to Do the Model Work, Not the Data Work"? No? Nobody? Highly recommend reading that paper. This is one of the figures that it's excellent talking about the technical debt and the data cascade in an AI system, where when we're looking at traditional or like typical AI machine learning workflow, starting from the problem statement setting to data creation and cleaning, and then the model selection, training, and evaluation, all those arrows means the impact of specific components into the downstream tasks. And oftentimes, when the authors was looking at interviewing different developers, they found that the data has a really strong impact on the downstream tasks, especially can cause negative and downstream effects from data issues that can result those like issues over time and often leads to abandon of the restart of the entire process. And if you really don't have a good data foundation for AI system, those systems usually will lead to non-adoption or abandonments in the process. So that really leads to the discussion about how, as a community, can we enable and make it more efficient of the adoption of AI machine learning systems, especially in the context of reliable and responsible use of those technology with our data in the context and Earth and space sciences, specifically we're talking about today. And the slides is not moving. Okay, and that leads to some of the recent development since 2017 of what's so-called data-centric AI. When we're talking about AI applications, often it's about code plus data. And when we're looking at the rapid adoption of data-centric AI, not necessarily in the geoscience, but overall in AI domains, there are three streams about data-centric AI. From training data development, that's one of the major streams, from collection and labeling, preparation of those data sets, to the inference when you're deploying them into the real world systems that leads to different type of evaluations in distribution, out of distribution as well. So it's prompt engineering, especially for large language models, etc. And then the one specific stream is about data maintenance that really understands the data and assure the quality of the data, as well as the storage and retrieval that leads to a lot of similarity with the data management and data stewardship in the community that we are quite familiar with. So since about a year and a half or 2 years ago, we started a data readiness cluster within ESIP, really trying to look at within the Earth and Space Sciences, how can we help users reduce their efforts in the data preparation side, and then leads to responsible deployment and development of AI efforts. So on the right side is a histogram showing in the survey we had for more than 100 people that they responded. Typically they spend at least half their time to work with data, clean the data, find the data before they can even put them through the system for model training and the deployment for their models. So the idea of a cluster is trying to reduce burden, make it more efficient and reliable for people to use those Earth and environmental data for that. So we're going to steer into our session today. There's two googly eyes, and there's a there's a line that's trying to support both two googly eyes. We're talking about two aspects. One is the FAIR principles, and one is AI readiness that class has been talking about, and what's the relationship and the connections between those two. And then we're also going to hear from the data repository and data centers perspective, especially from the World Data System, which is an organization with hundreds, if not thousands, of the member data centers, and how we can working with data centers towards the pathway for operationalizing the discussion and improvement of AI-ready data. So with that, I'm gonna turn the stage to Pen to give us a deep dive about some of the FAIR principle work she has been doing.
Hello, everybody. Can you hear me all right? Do you see my eye or my chain?
Let me see. Yeah, I think it'll be okay.
Good. Okay. My name is Go Payne, and I go with Payne. I'm a senior principal research scientist at University of Alabama in Huntsville, and supporting the NASA Impact program, which is all about improved data access and data stewardship. So we were trying to get, okay. I'm not machine learning expert, disclaimer. We're trying to get somebody from RDA FAIR for machine learning working group. However, we were not able to get one, so you'll stuck with me, the second best. And I'm going to talk about the FAIR a little bit. So if you're expert of FAIR, you can go sleep now. If you think FAIR is simple, and at the end of my presentation, you say, yeah, it's not that simple. I do my work. So FAIR data guiding principles, as probably all of you know, stands for findable, accessible, interoperable, and reusable. And it's a framework that's been formulated by 2016 paper by Wilkinson et al. And I have a code there, and QR code there if you would like to. So it consists of a set of high-level guidelines and to promote good data management and stewardship practices. And it's simple, they are very clever acronyms, and it's very catchy and it's positive. So who doesn't want to be fair? However, so it's increasingly adopted by the policy makers and funders and organizations. And if you look at under hood, and I'm not going to go through all the diagrams, it's a fairly complex framework. So I do have 3 diagrams there with different color, different shapes, and different directions, and that kind of indicate the complexity of the FAIR principles. I'm going to go a little more detail in the next several slides, and they represent 3 different categories. And one is the data, one is the metadata, one is infrastructure. We probably didn't think that was in there. And then here comes a different perspective. What does fair mean? So it depends on your perspective, depends on your applications. You may have a different interpretation what fair means. And this is old cliche, so same thing applying to fair. And that would, oh, I like that, that means the arrow. So as a result of the diverse interpretations and also domain dependencies and application dependencies, there are a variety of models, metrics, indicators are being developed. And we have looked at it a couple of years ago, trying to find one that we can readily use for us that's representing holistic view. And we are not able to, and also they're not harmonized because they have their own context of how they want to apply to their own purpose. So I'm just going to go back to the principle and not touch on any domain dependency, application dependency, just to see as it is based on definitions. So inheritively, the FAIR has 4 quality dimensions. And it has 15 principles. And like I have mentioned before, it has 3 categories. So the diagram on the right, the filled circles indicate, the bigger ones indicate dimension. The one to the next circle is the representing the principles. And there are 15 of them. And from there, you see the categories and either data or metadata by infrastructure. And if you go from there, you actually get to 28 category specific requirements. From there, we'll see that it gets more complicated. So this is one of the diagram flows from the FAIR as this representation of the framework goes through the dimension, goes to the individual principles. For each dimension, there are multiple principles, and from each individual principles, you can call them sub-principles, there are actually multiple categories. From the categories, you have a concept. And then to representing the different relationship from the subject, object, you have object, you have verb that creates actionable steps for you to achieve that particular object. And then it's multifaceted because it's modulated by, for example, the concept for F1 principles is an identifier. Then there are additional elements to modify that identifier. It needs to be uniquely, globally unique, internal persistent. And you can do similar things, the mapping, concept mapping, whichever you want to call, and that reach different, give you this whole picture about the relationship. So here, for this slide, I'm going into just for findables, and fundable has the 4 dimension of, have 4 sub-principles, and if you go through same thing, then you see the object that I have the identifier for F1 and the rich metadata, et cetera, for F2, then you have, then you also have the elements. If we identify those core concepts associated with individual principles and identify them as unique ones, and there actually come up 12 unique concepts that can be used as a fairness quality measures and give you holistic picture if you want to say my data set is fair, rather than say, oh, I assign a data set a DOI, my data is fair. Or I use vocabulary, my data is fair. There are important components of being fair if you're looking at your data product fairness assessment, but they're not a holistic picture. And just kind of go into the little detail for one particular example here for a F1, which means the data metadata assigned an identifier, which is globally unique, internally persist. And that gives you two category specific requirement. One is the data assigned globally unique and internal persisted identified. Same thing for metadata. But from there, if you look at the data itself, then you could see they separate them into the core part that say the data assigned identifier that actually indicate like procedural process depends on how you want. This is something that organization can define. But then individually, you could say data identifier is globally unique and internal persist. In there, it's kind of give you this tiered, potentially, the fairness. So in a nutshell, without going all the details, and the FAIR principle is a framework, it's a vision they have to have. They want to promote good data management and the data stewardship. It has 4 dimensions, have 50 principles, and most of the principles there has the 3 categories, and has that would map to 28 principles, and have 21 concepts. Those are the object. And then from those 21 concepts, we have mentioned that there are 12 unique core concepts. We call them quality measure, and they have 48 elements and 85 plus indicators if you go through the same steps I did for the F1. And those are not touched on any domain dependency, application dependency yet, which I'm not going to talk about today. So I kind of alluded to that. If you break down the indicator into granular, you can kind of use them to measure your fairness in a layered way. So we actually using the quality measure, and we use those different layers indicator. We developed fairness quality metrics. And I have an example here for FAIR principle 2, which is rich metadata. That's one is actually fairly unique. It's a lot more domain and application dependent. I'm not going to touch on that, but I do want to say that you can define your level of fairness from the minimal stage, that you have a very basic set of metadata associated with that, and to the optimal stage, that you have a comprehensive and that the metadata elements for enhanced data discovery. So overall, that gives you a structured, systematic way to evaluate. You can also use that to reporting your fairness, because right now it's like my data is fair. If you look underneath of that, there's a spectrum of what does that mean to be fair. So the questions pertain to the session. Go back to the checklist. Is the checklist fair? So from my perspective, there are 2 perspectives associated with that. Is the fairness of the checklist as a product. So we can evaluate that across the checklist stewardship practices, enabling resources to fair. For example, the checklist now is published in Figureshare that has DOI. We know that kind of, that's satisfy the F1. So we can do similar thing going through the requirements. And another one is, if the data sets satisfy the checklist, does that enable them to be fair? So we can cross the checklist to the fair requirement and potentially identify, if they are, great, we can say yes. If you satisfy the checklist, we know it's fair. Or maybe we'll identify gaps. Perhaps we would be able to address that gap so that will enable us to say, yes, you will be able to do both. I think that's all. So I have a couple of 3 takeaways here. I just want to leave it there. Do you have time for
Thanks, Ben.
question?
Yeah, we have time for maybe one or two questions before we move on to the next aspects. And maybe just show us hands. After Pen's presentation, how much do you think you understand FAIR?
Oh, you still think you think a fair is easy? I want to talk to you.
I thought FAIR, I just thought it was the acronym, you know,
I thought it was the acronym and I did not know all of that, so thank you.
You're welcome. Good. I'm happy now.
Any other quick question? Yeah.
Yeah, I was just wondering, can you point us to any references that might evaluate the impacts of different quality metadata on AI performance, large language model performance, for example?
That's for machine learning expert. I'm sorry. Actually, there's one paper, maybe I would send the link to you on it's the OGC working group. They have done some systematic study and they are looking at the different types of quality and how to evaluate them and report them. I'm not sure if that's what you're looking for, but that come up to my mind. Okay, cool.
Yeah, and we'll link all those resources on the schedule web page, so you can always go back to there. And we already linked Penn's EOS article describing the harmonization of FAIR assessment and also the external link to a worksheets to do the assessments of those 49 different like categories and then 85. Yeah. So yeah, there are a lot of numbers involved in it, so you can go in to look at it. Thanks, Ben, again. So next, I want to just pick up what like Peng was talking about, two perspectives about the AI readiness checklist that the group have developed in the most recent version is about 6 months ago. And I did some of the basic analysis of the checklist with FAIR principles to see how is the AI ready data really fair, or is there any gaps we still need to fill in terms of our checklist? And the motivation, well, a brief description of the AI ready data characteristic defined by the cluster in about a year and a half ago, that we have 4 major categories, from documentation to increase the data usability on the quality information, to define the fit for purpose of data sets for the AI machine learning applications, and the data access to affect that can impact on the efficiency and reproducibility of the AI research and development process, and preparation to identifying the most common data service and tools to reduce pre-processing burdens on the user side, right? So those are the 4 areas we think that defines what AI-ready data means. And this is a collaboration with multiple groups, not just within a specific agency, but this checklist has also been adopted by one of the NIH Institute trying to assessing their health data and trying to apply that to the health domain to understand users' data needs and also to lead to the community standards and guidelines. And that has been highlighted in National AI Research Resource website for that specific data sets from National Institute of Aging group. And when we're defining the AI-ready data, we have 4 categories of activities we want to pursue. The first one is the AI-ready data standards or guidelines from the community. And the second step is to the automatic tools for the readiness assessment, especially that is gearing towards the data managers, data centers, data repositories. And the third component is to improve the existing data sets to make them towards the roadmap or towards the journey into AI ready. And the fourth component is the engagement with the users and really also the capacity building to help people to use the data, especially in the right way. So we also identified short-term to long-term goals about those specific components of it as well. I'm gonna just try to lighten the mood up a little bit why we're talking about the fairness and AI-ready data and using my favorite book, also somewhat favorite movie. Some of them are okay. Um, out of the 8 movies, and some of them are okay. And those are 3 characters in the Harry Potter book and movie. And so I think that represents different aspects or different streams in the data management, where Ron comes from a family that has been doing magic for a very long time and has represented the existing data management, and sometimes may got overburdened with different things that are happening, and with others, with sometimes people call it unfunded mandates and other aspects of it, or the legacy system, whatever you want to call it. With Hermione, that with the fair principles that comes with all those equipments and knowledge that she has and that comes in, sometimes can, well, especially in the first movie, she can get on the bad side of the other 2 at the beginning, because everything comes in and then all of a sudden all the data manager need to also stick to the data principle without a lot of those guidance and all the things that Pam was just describing. And then with Harry, that with a lot of the fame and all those like hype related to AI-ready data and everything that happened after that, right? Now you can add analysis-ready data, you can add cloud-ready analysis-ready data, or Oracle and whatever new words you want to put up there. And so it's now we have 3 streams, and how, especially thinking about from a more larger systematic way to harmonize some of those efforts to reduce the repetition of some of the work and then make things more efficient, especially when we are on our way to modernizing our data service and data management and stewardship. Now we're going back to boring slides, different bullet points and everything. So going into specific things about the checklist we have defined, from quality to documentation to access and preparation. Each of them outlines a specific components we want becomes guiding documents for both data producers as well as data managers to think about how they can improve their data set through data management modernization, especially a lot of places going through the data cloud transition, right? So that is a unique opportunity for us to modernize a lot of data management practices. For example, just looking at documentation, that standard common metadata has been going on for a while. Just thinking about Ron's family, have been in the magic Department of Magic or Ministry of Magic for a long time. They've been doing with those metadata for a long time. That's not something new. But then things new are those computational notebooks, right? That it doesn't exist like 30 years ago. But now every users want to use computational notebooks to have an example easy to use those data set directly. So how can we harmonize those different things together to make things much easier? And so I think the core characteristics of the AI readiness really aligns with different ongoing discussions on the data management modernization and across different communities, like the fair compliance, fair assessments, and also the cloud native, cloud friendly modernization transition for different type of data sets. Well, for people who are new to FAIR, this is the basic version of FAIR principles that at the very beginning, Pam mentioned from the 2016 Wilkinson paper. F stands for findable, A stands for accessible, and I stands for interoperable, and R stands for reusable. And within each, you have specific statements that you should strive to satisfy to meet those statements from the global unique and persistent identifiers and other things like that. So I'm now going to go through with the AI readiness checklist documents. You're not going to go reading individual items on the checklist, but I'm just trying to group them into different categories. For data documentation, we're talking about the metadata and its compliance with community standards. And we're talking about data vocabulary, the data identifier, and some aspects of user support and data use cases, which may not necessarily represented in the FAIR principle or some of the FAIR assessment areas. But we also talk about data license in the data documentation for the checklist. Now, how does those map into fair assessment or the fair compliance? That can roughly maps into F2 principle, which is the data are described with rich metadata. So that corresponds to the metadata components. And the I1, which is partially I1, that data are used a formal, accessible, shared, and broadly applicable language for knowledgeable representation, as well as R1.3, which meets domain relevant community standards. So ideally, if you answer yes to all those checklist questions, that should ideally lead you to the compliance with those principles, right? And the other aspects is that for the metadata, using the vocabularies that follow fair principles that helps you identifying the meet the I2 principle, where for the DOI, persistent identifiers, that helps you to be compliant with F1 principle. And then there's also in the documentation that helps you, if you check those with the data usage license, that also helps you comply with the reusable 1.1 principle. So we can go through the same thing with data access, where in the checklist, we talk about data formats, we talk about access mechanisms, how those data can be delivered, can be accessed, and whether that requires user registration or not. And also we specifically mentioned about data security, especially for those restricted data types, for security, for privacy, and for other reasons. So if you want to map it to, that can be the accessible components of the FAIR principles, A1.2, A1, and A1.2. I don't think you need to understand what A1.2 and A1 at this point means, but it's really, the idea is that if we can crosswalk those information between our AI readiness checklist and the FAIR principles, especially the most detailed FAIR principle implementations that Pam was mentioning. So when a data center or data provider or data producer complete one of the checklists, that can help you automatically be qualified or eligible for the compliance with another one. So in another way, we're trying to see if those activities, the cross mapping between the existing tools can really help the data centers and data providers more efficiently to meet multiple requirements in one improvement or in one assessment. And specifically, one thing about data quality, originally I thought that doesn't really matter. It doesn't really relate to FAIR principle. So for example, why we think data quality is important, so ImageNet is a data set I mentioned that really important to push the data computer vision in the area, in the age of the explosion, is ImageNet and its associated label data. But now there's people trying to look at errors or the accuracy of the labels from the ImageNet. Right here are just 3 examples that I directly picked from the website, labelerrors.com. People are trying to identify all those errors. So on the left image is the ImageNet given the label of the sloth bear, which typically it should be a brown bear. And then on the right side, you should be a Yorkshire Terrier, but then the label given is a Yorkshire Terrier, but then it actually should be the Border Terrier. So all those labels, although it's for animals right now, but there can be downstream implications if you are using specific real-life applications using Earth and space science data, thinking about those high-impact weathers. If we are using the wrong label data sets for the training, that can lead to the misclassification and can lead to the high economic and human life impact as well. So when we're defining the quality in the AI readiness, that we're talking about completeness, consistency, bias, timeliness, and bias continuous, there are a lot of questions about bias and the process, how to assure the quality and the provenance and the traceability of those data sets, right? So when we're thinking about the trustworthiness of the application, we want to know the traceability of the data that feeds into the model itself. And originally I thought there's nothing to do with FAIR principle, but when we're thinking about it, and everything is really related to the reusability or reusable of the data itself. So that means that R1 principle, the metadata, are richly described with a priority of accurate and relevant attributes. And that is part of the quality, not just for data quality, but also the metadata quality as well. And then other aspects of quality is R1.2, which is another principle called metadata associated with detailed provenance. We're talking about provenance of the data set and how it may have impact on the downstream applications for AI and machine learning applications. So that is also an educational experience for myself. I thought quality has nothing to do with fair principle. It's just an extra requirement from for the AI-ready data. That actually turns out it's not the case, and we can have a lot of the communication can happen between the fair principle implementation and the AI readiness assessment improvements. So now here, just a really brief, really like cruel mapping between the checklist of AI readiness of the documentation, access, quality, and preparation on each row. And then for the FAIR principle, the findable, accessible, interoperable, and reusable on the column, right? So for the documentation, if you meet all the requirements for documentation part for the checklist, you'll be able to satisfy the F1, F2 for findable principle, and I1, I2 for interoperable, and R1.3 and R1.1 for the reusable. And if you meet the access requirements for the checklist, then you meet A1 and A1.2 for accessible principles in FAIR. And for the quality, it can help you to meet R1 and R1.2 for the reusable. I know now I'm just spitting out the letters that you have no idea what they represent for. But the idea is that currently existing AI readiness checklist doesn't really address some of the FAIR principles, like F3, F4, and A1.1, A2. And those are the areas that, as a cluster and as a community, we can work towards enhancing the checklist that's currently published and make it to either identify what's the gap between the checklist and the FAIR principles and harmonize those things together so that can make it a little bit better for the data centers and data managers to use one tool that hopefully can meet more than just one goals. So with that, I'm going to stop for a question before we turn it over for a data center's perspective. Yeah, we have a question. Do we have mic?
So I think you touched on this, but are there any AI-ready requirements that are not met with the FAIR framework? It looks like preparation.
Yeah, preparation.
All, right?
Yeah, preparation doesn't.
Completely missing.
Yeah, doesn't touch any FAIR principles. At least right now, from very basic interpretation. But those are really common, like data preparation services. People are thinking about identifying outliers. I guess that can, if we really dig into details of really specific categories, it may help map it into a specific FAIR category and principles.
And the second question.
Yeah, sure.
That's okay. Is there any software that you know of that can validate fairness of data?
Well, there's some, and one of them is called Fuji, that's developed by European Commission. They have a FAIR, the European Commission, they have a project called Fuji. If you give a landing page of data sets, it will automatically give you assessments of how that meets the FAIR principle, but it's not the perfect implementation. So it's a great first step, but I think there's a lot of room for improvement as well. F-UJI, Fuji. And Penn may have something to add as well, so.
And I have a quick question about how the FAIR and AI readiness is actually evaluated. From what I've seen so far, it's mostly just been about checklists and going through various, okay, is this right and everything. Is there any example, like, during this process, is there any example of, like, going through a Jupyter notebook or some type of example of a machine learning problem that's actually used in this process? Because I would like, I guess from what I've seen, I would like to see a little bit more hands-on to test to actually see, okay, here's some actual ML use cases that the data can actually be used for in order to move forward.
Yeah, at NOAA Center for AI, I have a few of the pilot projects on specific data sets. One is for tropical cyclones. It's called PC Prime dataset that is on NOAA Open Data Dissemination, as well as going through the archive process will be made available through NOAA NCEI as well. That one has 8 different notebooks, and with specific notebooks on machine learning applications, and they're developing new notebooks as well. Another one is the water past the water sonar acoustics, underwater sonar data, that there's also 6 notebooks associated with it, and we have multiple ones being published throughout the next 2 months on lightnings and weather simulation, post-processing, as well as other rip currents as well. All right. Pen, do you have anything to add regarding the question earlier?
Yeah, I just want to touch on the tools. So the one Douglas mentioned, that's automated one. The limit there is you can only check what you can check. Some of the requirements of fairness, you can't really automatically check. And there are also other tools like the FAIR implementation profile is the manual list. You can take that has the requirements, and you can put the FAIR enabling resources there and kind of make your own evaluation template. So there are a number of the tools. Those are the tools used mostly by the community.
Thanks, Ben. I think there was one more question there.
You touched on ImageNet having some incorrect identifications, and so that made me think about quality, whereas a lot of data sets do not have the quality or fit for purpose designation to them. What should or would be a workflow if something's been out there for a while, like with ImageNet, and it's been used for AI, and then found out that it is misinterpreted and used that in predictiveness, and then how would you fix that in the workflow? So you went back and you changed those in ImageNet, and something's been using that for years. How would you identify? How would you change that? How would you let people downstream know of that?
Yeah, I think that falls under the data maintenance workstream for the data-centric AI, where you really have to, yeah, I think he's trying to get the mic back, so you're not attacking me for another question. So is what I was talking about data maintenance, right? Once you identify the issues, that you will go through the cleaning of those data, and then you have, ideally you have a way to notify all the users, but that is really hard. And so that becomes a challenge with like ImageNet, especially when you have multiple versions being used or being available on the website, and the provenance and how things have changed throughout time and who use which data set to train their model. That becomes not just data problem, it's become the workflow problem, where there's a whole group within the Research Data Alliance working on FAIR for workflow and to identifying the traceability of the workflow with the linkage to data sets, the linkage to software, and which version you're using, how that creates the outcome. And going back to data set perspective, there's some development called data valuation that helps you identifying the contribution of individual labels or individual pair between the input and outputs, and identifying which one has most impact in the model itself, in the model performance itself. So that gives you an idea of whether the error in that specific data pair between the input and output has strong impact or not. So that is all coming from information theory, with trying to do the perturbation of the data set and data pairs. And that's only developed in the recent 2 to 3 years. And now people start using that also in the geoscience domain as well. Right. I think with given time, we're going to move on to our last presentation before our discussion with Raina Jenkins on from the World Data System. Right, use this or just use this.
Okay. Okay, thank you. So I'm Raina Jenkins. I'm representing the World Data System, and I'm giving some of our concepts of what we're planning on in the next while, based on our perspectives and some of the pursuits and partner engagements that we're kind of just in the early stages of. So, I mean, in keeping with the CARE principles, I'm going to going to give a Legacy acknowledgement as well here. So I'm from Victoria, BC, and based at the University of Victoria. And there we acknowledge and respect the Lekwungen, Songhees, and Esquimalt peoples on whose territory the university stands, and the Lekwungen and Wasanich people whose historical relationships with the land continue to this day. But what I really want to emphasize again that we've seen is the care principles, and that's super important for our community to continue to recognize. So I'm going to talk a little bit about the World Data System, and this is to put that perspective into context and really describe like why we're interested in doing something on this topic, and then get a little bit into that perspective of some of our pursuits and partnerships that we're beginning and already started in some cases, and then just a little plug for an AGU session that we have coming up. So just a little bit of historical context. I'm not going to go through all these dates, but just for those of you that don't know anything about the World Data System, we are an organization that's spun out of efforts from the International Science Council and its predecessors, and all these international years, like the International Polar Years, International Geophysical Years, which led to World Data Centers for data sharing. But then it wasn't until about 2008 that the World Data System, as it is today, kind of was created to help with that coordination between data repositories around the world. And then the technology office that I work for started in 2018, and that program office that was originally launched in Japan moved to near here, 2 hours drive away to Knoxville, Tennessee, in 2021. So there's a bit of a long-standing history, even though the organization itself is only about, I don't know, I guess 15 years. So it's very international in terms of our membership, but also our science committees, so that they govern what we do, and they represent all kinds of different disciplines around the world. And we just had an election process for filling in some of the rolling off members. So this is our current slate of science committee members today. And then I already mentioned where we're based for the 2 offices, but it puts it on a map. And then our membership is mainly certified data repositories. That's via the Core Trust seal. So that's the bulk of what we're there serving. But also there's other flavors of the data ecosystem that are members, network, partners, associate. For example, ESIT is a member partner organization. And then many of you belong to repositories that are part of our membership. But then there's also an opportunity for those repositories who may not be certified yet but want to be involved. We have this candidate category as well. So basically our mission is really to support the data repositories, but that is, of course, is helping things along with that life cycle of data, scientific enterprise, and also really promoting the data access and reproducible science. So that's what we do. And I started a year ago and then at the World Data System. And when I first started in October, went to International Data Week and was part of a plenary session where we did some polls, and this is where I was starting to figure out, okay, where do we need to go? What are the directions we need to take? And so one of the polls was about how ready are we for artificial intelligence to the audience. And you can see we weren't, this is last October, not doing that great on anything. But machine ready data, falling back there. Training data sets, of course, another problem to tackle. So this was definitely an area I knew that we needed to do more on at the World Data System. And then, of course, this wonderful paper that was co-written by some of the colleagues here came out in November that I really liked, emphasizing the importance of data in AI as trying to mitigate this problem of the garbage in, garbage out phenomena that we can see with models. So we've gone over some of this already. But what I really liked in that paper is this paragraph that really emphasized the importance of the data repositories, and particularly disciplinary repositories that have that robust, more curation, completeness, comprehensiveness to the metadata that allows for that reusability and interoperability. I know generalist repositories can be great, but they tend to have less comprehensiveness when it comes to the metadata. And so this was really important and great to see that role for disciplinary repositories being emphasized in AI data readiness. So we've already gone through the checklist, so I'm not going to go over it again, but certainly this is a partnership that we thought was a really great partnership to have to move the repository community closer and to evaluate this checklist. So we'll be working with this through our pursuits listed here. So in the fall, we're planning to have a workshop with our World Data System membership, and this is broader than just the Earth and Ocean Sciences domain. So we'll introduce this checklist to that participants, and we're going to hopefully get some preliminary feedback, but really try to do some pilot executions with diverse geography and disciplinary repositories to start to see, is this holding up in different cases? Are they finding gaps? Do they understand the questions? And just trying to get some pilot feedback to that, and then hopefully refine the checklist based on our findings, and then move to that automated work that could potentially build on the tools like Fuji. That's the one that we're most thinking about. I'll point out that Fuji is based on, right now, the schema.org metadata and the DataCite metadata combined. So we might want to extend for disciplinary content into the data files as well, or we'll have to look at that, what makes sense. But try to fill in some of those gaps, what makes sense, that some things that we can't get out of schema.org or DataCite metadata, and that we might need to dig deeper into the files or other formats of metadata. So another thing that World Data System is doing is, with our affiliation of the International Science Council, there's the International Science Council for Center for Science Futures that has a thematic area of AI. And David Castle, who is our science committee chair and also my local ITO principal investigator, he's the project chair of this initiative. And so he's been very active already, and they've had a couple regional workshops so far, one in Kuala Lumpur last fall, and then one in Santiago de Chile in this past April, looking at how nations are ready or not for AI. And they put together a report. There's a literature review that they did, and they boiled that down to 3 thematic areas of things that need work, and then 12 country case studies based on countries that participated in those workshops. There's another report coming out this fall with more case studies, and then they've also now have additional funding for the next 3 years to keep going on this work. So we're going to be looking at what areas that we are doing in the World Data System on data readiness, how that can factor into what the Center for Science Futures is doing. And another avenue I was recently introduced to is climate change AI. So how many of you are aware of climate change AI or a member of the community for it? Okay, it's a very big community, as I've learned. So there's thousands of people on this community. So it's very active, actually, with the forum and training and all sorts of things. So it's a pretty good avenue to reach actual people that are on the user side. And they actually also in 2021 had a report that came out highlighting the importance of fostering more access to data and digital infrastructure for their purposes. So that's good to see. And also they have, this is maybe a good way to partner the repositories to application developers with data access and identifying what their needs are. They have wikis and with a data access section that you can actually post data sets that suit certain purposes. So it's an avenue for promotion, both on their wiki, but also through their newsletters and their forums. And they actually have this call for proposals that just launched like last week about climate change AI innovation grants. And actually they have a subsection, a special track on data set gaps. So that might be an opportunity as well. So there's other partnerships we've been starting on, looking into. So we've just started participating in the Fair for ML interest group meetings. And one thing I'm interested to see what's happening there is they're working on putting together a Delphi study to identify top 10 fair practices in AI and ML. So they're at that brainstorming stage right now and should be having the survey out, I think, soon. And then we'll be participating in the Fair and ML AI Readiness and Reproducibility Workshop. That's this October. So I just got yesterday the approval of the poster submission. So we'll be providing updates on the workshop because that will be just after the workshop when we go to that. And then another new development is partnering with Latin America open data initiative, so having reached to the Latin America countries, they have a focus area for AI as well. They're really interested in the ethical piece, especially that trust of the data and ethical use of the data in AI systems. So that's really important in that region. And so we're open to other partnerships, like we're trying to be multidisciplinary, trying to be geographically representative, but certainly building on tools and what's already out there, not reinventing the wheel. So just a little bit of a promotion. So Doug and Karen Stocks and I are co-conveners for a session at AGU. So you have until July 31st if you are doing anything in this realm of advancing AI data readiness. So this is the abstract. I won't necessarily read it word for word here, but we're really looking for good examples of those in the repository community or those that are pulling together data sets for the purpose of machine learning or AI. So if you're doing work like that, please consider to put in a submission to that before the deadline next week. Just another putting on your radar too is International Data Week. So World Data System and the Research Data Alliance and CoData work together to put International Data Week together every couple of years. So the next one is October 2025 in Brisbane. So I'm certain there will be AI themed related content there. And along with a host of other data topics. So session proposals will be called for later this fall, so be on the lookout for that. And yeah, we're already in planning mode, so should be an exciting time in a couple of years, I guess less than 2 years. So just a shout out to our funders, both in the US and Canada. And then, yeah, if there's any questions, happy to take them, but I don't know if there's time.
I think we have time for 1 or 2 questions.
Oh, okay, maybe it was clear or not.
No questions,
thank you.
okay. Great, so thanks, Raina, again. And now, as I stated in the very beginning, we specifically put towards in the session for a reason, right? We don't have all the answers for the things we're talking about today, and then we want you again go to scan the QR code, and that will be 3 questions. And what I want you to do is not putting individual answers, but I want you to have a 5-minute discussion with your neighbor. So 2 to 3 people pair up. You don't have to go across the room, just find the people who are sitting next to you, briefly discuss what's your current thoughts on issues on this specific topic. There are, I kind of like sneaked some prompt engineering there as well. Imagine you're a data user, imagine you're a data manager or data creator, and imagine yourself as a data center manager. So what are the information services and can help you to find the right data sets as if you're a user? And for a data manager and creator, and what can help you most make your data fair and AI ready? And then if you're a data center manager, what can better help you to create or scare you to implement fair and AI ready data recommendations. So now we have about 5 to 8 minutes pair up in the discussion. So for the people who are online, can Deb or Jane, can we create a breakout room, put everyone online into that breakout room? Yeah. And once you have talked about it, and just enter your answers into the form, right? Also, briefly introduce yourself to each other as well. All right, I want to get everyone's attention back we can go through some of the responses from people submitted after the discussion. So right, that we see this is word cloud coming from all the things that you have submitted as a data user, what's the most important information and services, like I think usage example pop up really on the top, and then there's also searching. If I go to our responses, you'll see a lot of people, oops, that's upbeat. Guess everybody is getting ready to party at the poster and showcase. And the Google search pop up like multiple times. Like seems like it's very common. Everyone, if we want to find a data set, Google or some of the data set search engine become the most common service we're using. And so I want to just see, because we have a few minutes left. So anyone have any specific questions or comments regarding the discussion or reflections that you have just talked about? Any question, it doesn't have to be whether for data user or for creator, manager, or the data centers. Don't be shy. Also, we have people online. I see there's still, is Leslie and Rob? Yeah, I see Leslie and Rob are also still online. So if anyone online want to say specific things, that's people are really ready for party. Yeah, Raina. Mike. Oh, okay. Yeah, and there is a recent development called something called Croissant, which is from the ML Commons, which is a group driven by industry and academic researchers, mostly trying to create a high-level data structure based on the schema.org to represent training data sets in the machine learning that integrates both in the dataset search and the access of the data through the data science framework like PyTorch and other things directly. So now that has already been integrated into Kaggle, OpenML, as well as Google Dataset Search, because Google people are involved in that development as well. So now if you search a data set that has a Croissant metadata implementation that you can directly open it up with a Croissant reader to look at the data before you ingest that into your workflow for machine learning development. And the next step, we're trying to extend that with geoscience specification. So that is a collaboration. It's currently at the beginning of the discussion and the implementation or development stage. So we are working with Marshall Space Flight Center, the NASA Impact Group, panelists was, and then there's also people from King's College London and Google Earth Engine, and different groups are all really highly interested in that aspects, just because, well, for Google Earth Engine people, they want to make their data easy to discover for the people who are using machine learning algorithm for developments. And for us from the earth science side, the repository side, that is really interesting to see how those high-level data structure can be integrated to kind of like machine, to make the AI readiness checklist in a way more machine actionable directly. So that is one way we're collaborating with others in a partnership. I see there is, oh, there's the chat going on, thanks. Any other comments, questions? Yeah, Justin? Do we have a mic?
I would just like to mention, I was discussing this with Andy Evans, well, during the discussion meeting. I was wondering if, we can use generative AI and LLMs and vector databases for older legacy data sets that may not have the metadata enriched there. It'll take a really long time to go in and plug that in manually. I wonder if there's a way we can use vector databases and stuff along with, because I've done some cosine similarity work with GCMD keywords in the past to actually enrich some of these data sets in a more time efficient way so it can meet the fair care standards.
Yeah, I think, and I know, well, the Marshall Group has also been doing something similar for the machine using large language model, trying to recommend some specific metadata improvements as well. So I'm not sure you're involved in that Well, pen.
Not really, but I do know they also use it to get like a metadata curation for different data sets. And that can be, help improve the curation process because as you mentioned, metadata can be very intensive, tedious.
Thanks. Other questions or comments? That can be any comments about the session or discussion you have seen today. Very quiet, low energy. That's okay. And we can end our session earlier, a little bit earlier today, and then give you 5 minutes because it really needs 5 minutes from here to walk to the expo center to the poster. So just a follow-up for our discussion today. We have our monthly meeting at every second, well, I forgot. Every second Tuesday of each month at 1 p.m. Eastern Time. You can find that on the ESEP calendar. It's open to anyone who want to continue the conversation about AI-ready data. And October, we have a virtual workshop with our data system with different membership data centers. And every event, we're also going to advertise on the ESEP's newsletter as well as our mailing list. So you can find data readiness cluster on the ESEP website. Right? Thank you, everyone.